Question 10 comes in three parts. The first part asks us to find the general solution to this differential equation at the top. The second part asks us to find the particular solution that will pass through the origin, or rather x equals to 0, y equals to 0. Third part will ask us to use our Maclaurin approximations to approximate our values for x and y. We'll get onto that soon enough. Let's take a look at this one first though. This one looks a bit intimidating because of all of the trig, but truth be told, it's actually fairly straightforward. First thing is we move the cosine to the right hand side, so all of our x's are on the same side of the equation, and then multiply through by cosine x. What does that give us? That gives us dy by dx on its own is equal to sine of 2x, because the cosine x here and the cosine x here will cancel, minus, and then when you multiply this one to, plus, multiply this to cosine x, we get cosine squared x. Next, we can't integrate this directly, cosine squared x directly. Instead, we've got to change its form using the double angle rule. What is the double angle rule? Well, we know that cosine of 2 times some angle A is equal to 2 cosine squared of A minus 1. So, rearranging, we find that cosine squared of A is actually equal to a half cosine 2A plus a half. So that's what we're going to do. Dy by dx is equal to sine of 2x plus a half cosine 2x plus a half. Now, if I look at this, this is what I can solve using direct integration. I find that y is equal to a half cosine, negative a half, cosine 2x plus a quarter sine of 2x plus x upon 2 plus my constant of integration, c. I have to now find the particular solution that passes through the origin. Well, that means when x equals to 0, y equals to 0. So what do I get from that? I get 0 is equal to negative a half times cosine of 0. Cosine of 0 is 1, plus a quarter times sine of 0. Sine of 0 is 0, plus 0 upon 2 plus c. So that's going to tell me that c is equal to negative 1/2, and that gives me my general solution as y is equal to negative a half cosine of 2x plus a quarter sine of 2x plus a half x minus a half. Sorry, c will equal positive a half. What am I talking about? And that means, if I just tidy this up a little bit, y is equal to a quarter sine 2x minus a half cosine 2x plus a half x plus 1. The second part of question 10 says that given this equation, given the solution that we found, for small x, find the x such that 100y is equal to 1. So recall that we found that y is equal to a quarter sine of 2x minus a half cosine of 2x plus a half x plus 1. So what do we do? Well, we know we've got certain approximations from our Maclaurin series expansion of sine and cosine about the point x equals to 0. We've got approximations for these expressions now for small angles of x. That is, for small x, sine of x, or sine of some theta, so for small theta, sine theta is approximately equal to theta, and cosine of theta is approximately equal to 1 minus theta squared over 2. And if you look at these, what these actually are, these are the terms of the Maclaurin expansion of sine and cosine up to the x squared term, up to and including the x squared term. So we're going to use these approximations to help us solve this problem up here. One other thing to note is that if x is small, then 2x is also still quite small. So we don't have to go through the entire rigmarole of converting these into separate fractions. Like we don't have to change this into 2 sine x cosine x. We can just use 2x as our angle. So what does that give us? That gives us that y is approximately equal to 1/4 times sine of 2x, and sine of 2x is approximately 2x for small x, minus a half. Cosine of 2x is very close to 1 minus 2x squared over 2. So 1 minus 2x whole thing squared over 2 plus a half x plus 1. So what does that give us? Well, this gives us 1/4 times 2x gives us a half x minus, and we get a half, plus, this is going to be 4x squared divided by 2 times a half, going to give us x squared, plus another half x plus a half. So when we look at this, what do we see? We see that this and this cancel, these two combine, and what we are left with is x squared plus x. So therefore, 100y will be approximately equal to 100x squared plus 100x. And therefore, the equation we want to solve is 100x squared plus 100x equals to 1. Or rather, 100x squared plus 100x minus 1 equals to 0. So you can plug this into your graphing calculator and it will give you an answer. The answer it will tell you is that x is equal to 0.009902 or x is equal to negative 1.0099. Which one should we choose? Well, this one we should reject. But it's not because it's negative. That's just a coincidence. We're rejecting this one because we needed x to be small. Remember? This is only valid for small x. So we choose the one that satisfies the condition when x is small. So this is our answer here. And now we are done.